I want to do one last example with this little hierarchy that we're building of animals and rabbits and cats and people and students. I want to do this to introduce one more idea that can be really valuable. And to set the stage for this, with instances, we've already seen the idea of an instance variable. In fact, those are the things we've been using. Those data attributes, those variables are stored inside of each instance. They're specific to that instance. And so when I create an instance, they belong to it. I can use generic variable names within the class definition to get at them, but they're all things that belong to the instance. I'm now going to introduce the idea of a class variable, similar to an instance variable. This is going to be a variable defined inside the class definition, but outside of any of the methods, so outside of init. That's important. If it was inside init, it would be something that would be created within the instance. Here it's going to be something that belongs to the class and therefore is shared among all objects or instances of that class. It means any instance of a class that I create can get access to that variable. And we'll see why with an example that shows why this is going to be valuable to use. So, this just reminds you, there's the animal class, the kinds of methods we had. And I'll just simply remind you here that these are instance variables. Age and name are things that are created whenever I call init, which means whenever I create an instance. They can only be accessed from within an instance. I want to see what happens and why I want to have the value of having a class variable. So, subclasses, we know, inherit all the data attributes and methods of a parent class. And so I'm going to change the definition of rabbit in an interesting way. I'm going to put a tag on a rabbit. It could be a little ear tag that I'm typing onto it, but I'm going to tag every rabbit. So notice what I'm going to do here. Rabbit is still going to inherit from the animal class, but I'm going to create a class variable. And notice in particular, it is outside of the init definition. It's at the same level as those things. So when I create the class of rabbit, it is going to create within that frame associated with rabbit a binding for tag, initially set to 1. And that tag is going to allow me to give a unique ID to every new rabbit that I create. So now my initialization method for rabbit is a little bit different. In particular, I'm going to ask to pass in potentially 2 other arguments besides age. 2 parents, 2 other rabbits, because rabbits breed rabbits, as we saw when we did Fibonacci. I'm still going to initialize an instance using the underlying animal init method, as I did before. But now I'm also going to set, within that instance, parameters or bindings for parent 1 and parent 2. And those get set by simply taking the values passed in, which default to none if I don't pass 1 in. And I'm going to do one last thing. I'm going to create a local rabbit ID tag, or an RID, for this rabbit by accessing rabbit.tag. And that's going to get me to this point. It means the first time I call this instance, that instance is going to have as a local variable RID, and it's going to be the value 1, because that's the current value of the tag. And then the last thing I'm going to do is, having called that instance, I'm going to increase it by 1 to 2. And that means that the class is keeping track of the tag, and every time I call init again, I create a new instance of this rabbit, that instance is going to get a unique ID, the latest value, and the tag is going to increment by 1. That's cool, and this is a place where I've got data attributes associated with the class, not with the instance. Okay, let's see what happens if we do that. And that's simply reminding you of those pieces. An instance variable, how I access it, and the fact that I'm going to increment it every time I call this piece. So, having done that, there's a couple of other things I can do with the rabbit. And in particular, the getter methods will include now getting out the ID and getting out the names of the parents. The one other thing I have here is that I've got also getters I know for get name and get age that are inherited from animal. I can use those as well, but these are now things specific to the rabbit. And the one last piece here is, since this is actually a particular string, because I've set it to be string, I can fill it out with zeros to pad it so that they all print out at the same size. You'll see that in a second when I use it, but it's a little technique to basically make sure that everything prints out to the same size. In this case, it'll be 001 rather than 1, so that the things look and print similarly. Okay, let's use it. I create Peter, a rabbit of age 2. I set his name to actually be Peter. That's kind of nice. That's his name after all. I'm going to create another rabbit. Hopsy is of age 3. and I set her name to be Hopsy. And I'm going to now create another rabbit, Cotton, that has two parents. Peter and Hopsy got together. Cotton's 1 year old. And if I set Cotton's name to Cottontail, that's fine. But if I want to look at things about Cotton, if I can print it out, and again, Cotton is now an animal with with the name Cottontail inside of it and the age 1. So I've inherited all of the behaviors I would have wanted before. If I ask Cotton to get the first parent, I can print that out. And notice what I'm doing here is getting a method associated with that and then invoking it. And it prints out, exactly what I wanted. Cotton's first parent was Peter, age 2. Okay, once I've got that, I can add some other pieces to my behavior for rabbits. In particular, I can define, as I said earlier with classes, there's an inherent add method here. And what I'm going to do is define a method for rabbits. What does it mean to add a rabbit? Okay, so I've got an initial method here. Initially, it's simply going to return a new rabbit. And that new rabbit has two parents. This particular rabbit and whoever that other rabbit is. It's another way of saying I'm going to let the rabbits mate. And I'm going to create a new rabbit with that call to rabbit right here with parent 1 and parent 2. Let's look at an example of that. Before I do it, let's simply remind you what this is doing. The add operator is between two rabbit instances. It defines what it means to take rabbit 1, rabbit 2, and add them together to create rabbit 4. Initially, it's a new rabbit. I'm going to have it be a new rabbit with age 0, coming from right there. It has self as one parent and other as the other parent. And ideally, inside of init, I should check that, in fact, they are of type rabbit. I haven't done that here, but it would be a nice thing to do to make sure I'm enforcing the invariant that these are rabbits that are getting together. I go back to Peter and Hopsy, and I can now say, let Mopsy be what I get when Peter and Hopsy get together. I'm using rabbit addition. I'm creating a new instance of a rabbit. I'm giving it a binding of Mopsy on the outside. I can set its name. And now I can say, what's the parent of Mopsy? It's Peter. And I can say, what's the other parent of Mopsy? And I get out Hopsy. I know it's a silly example. What I've done, though, here is take the idea of given instances. I can now define what it means to do addition on those instances. It's up to me to decide them. And I used it here to create new instances of a rabbit. The last thing I want to show you is how I can use that idea of those tags to actually define what it means to compare two rabbits. What does it mean to do equal? Or what does it mean to say R double equal P, for example? I'm going to define an override of the EQ method, a built-in method. And here what I'm going to do is say, I'm going to decide that two rabbits are equal if they have the same parents. I could do it some other way. I could do it to say two instances of rabbit are the same thing if they have the same ID tag. But here I'm going to say they're equal if they actually have the same parent. How do I do that? Well, I'm simply going to look at the tag associated with the instance for each parent, both for parent 1 and parent 2 of self and other. That could be they're the same parent 1 and parent 1, parent 2 and parent 2, or they could be the other direction. And I'm going to return true if one of those cases is true. So I'm setting up Booleans here. And what I'm doing is relying on the fact that I built a unique tag with each instance of a rabbit. And if I do that, I'm simply comparing those tags. I know they're unique because of the way I define them. And if I didn't do this, if I just said, are the instances the same, I'm actually going to get into a problem where I'm going to get down to an attribute error because I can't compare the instances directly. So this is a nice way of doing that comparison. And if I try that, I create Cotton, I create Mopsy, and I say, is Mopsy equal to Cotton? Notice Cotton had parents of Peter and Hopsy. I created that directly. Mopsy has parents of Peter and Hopsy. I created that using add. And when I do the print, it says, yes, in fact, these are the same. So now I've got an example of using a class variable to gather information that I can associate with instances in a way that lets me keep track of information that belongs to each instance but is defined within the class. And so to pull it all together, what are we doing? We're bundling together objects that share common attributes and common procedures to apply to those attributes, even though the values of the attributes are different across each instance. I'm using abstraction to distinguish between how I implement something and how I use it. And now we've seen an example of building layers of abstractions with inheritance associated with them. And that lets us create hierarchies of behaviors while preserving clean code and efficient code by associating methods with each instance of a class that implement that common behavior.